potential bad effect upon the regional water table supply. So anyway, and again, if that should happen, let's say for a quarry or mine, I've seen the company involved would always take care of the problem. So anyway, there's your hanging water table. Now, aquifer systems. There are two fundamentally different kinds of aquifer systems. We call them unconfined and confined. So let's take the unconfined first. So here's the picture again. Surface, water table, and probably at this time, it doesn't have to be, let's sort of picture this as being a regional water table, although it doesn't have to be. Then down below, what you have are sort of a stack of aquifers and aquatards. We want to stay away from the aquicludes for the moment. So you have a stack of aquifers and aquatards. So here comes the rain down through, going down below the water table, and what it does, it sort of fights its way down through the aquatards. I mean, see, we're in no hurry in geology. It'll get through until it gets into the aquifers, and the water will then start moving through the aquifers. Now, here's a good question. Which way does the water move? Well, here's the general rule. The general rule is whatever way the surface water is moving, that's the way the groundwater moves. Why? Well, just think of your little chart. We drew that little cartoon of the hydrologic cycle. The streams were heading to the ocean that way, I'm saying. Well, the ocean's still that way, and that's what the groundwater wants to do too. So generally the rule is whichever way the surface streams are moving, that's the way groundwater is moving. But picture now the water in this particular aquifer. It can move along that aquifer, but there's nothing to keep it from going down through a crack into the one below or up through a crack to the one above. So the idea is that it's unconfined, you see. That's the unconfined part. The water really isn't confined to any one aquifer. It could go from one to the other. Now, we're going to talk about wells pretty soon. And if you drill a well into an unconfined system, here's what's going to happen. The water is going to run out of the aquifers that you intersect into your well, and the water will always rise to the water table, whatever that water table is, be it regional or hanging. So the idea is that water tables are involved when you drill into unconfined systems. The water will always rise to the water table. Now, the other kind is called a confined. Now, this is quite a bit different, so I have to sort of set the scene for this one. What you need for a confined system, you need a highland adjoining a lowland. Highland adjoining a lowland. Any scale you want. I'm thinking at home, there's a ridge line we call Chestnut Ridge, maybe 1,000 feet high. It's about 100 miles long. On both sides of it, there's a lowland, and Morgantown happens to be in one of those, okay? So that's one scale. On the other scale, you have the Front Range of the Rockies and the entire Great Plains. That's the other scale. So scale doesn't make any difference. So here's the deal. Under this, you have an aquifer. Now, you want a really, really, really good aquifer. So this undoubtedly is a sandstone aquifer that underlies the lowland, comes to the surface in the highland area. Now, what you want is all that be sandwiched between two aquicludes, a shale above and a shale below. And you can put in the regional water table if you want to. But here's the deal. The water falls as rain, soaks into the ground, heads down into the water above this particular aquifer. But note it can't get into it because of that aquiclude above. Okay? How does it get in? Up there in that ridge line, in that recharge area. And once the water gets in, it can't go up, it can't go down because of those two aquicludes. Now here's the big difference between the unconfined and the confined. The water in a confined system is under pressure. Now think about pressure as energy, because that's what it is. Pressure is energy to do work. The pressure you put in the tires of your car lifts the car off the ground so you don't have to ride on your rims. So the idea is that everywhere within that confined system now, the water is under pressure, just like you increase in pressure if you dive into a diving pool. It's exactly the same thing. As you go deeper below the level of water in this confined system up there in the recharge area, the water pressure increases. So what? Well, let's picture now drilling wells into that confined aquifer. The amount of energy you've got is enough to raise the water, theoretically, to the level of water in that aquifer system. So if you simply drew out from the level of water at the recharge area a horizontal surface and call it the ideal pressure surface, that's where the water should go, by theory. Remember, water reaches a common level. But if you actually do this by experiment, it won't. What happens is the water rises almost to it, but not quite. And if you picture a number of wells drilled away from the recharge area, out into this lowland, Each well, the water will rise, but not quite as far as it did in the first case. So as you go away from the recharge area, the distance that the water will rise gets less and less and less. And so rather than an ideal pressure surface, you have this sort of actual pressure surface coming out from the recharge area, sort of like an umbrella. Okay? Now, this umbrella, if you will, picture it, for a while it's above ground surface. Pretty soon it comes down to ground surface, and then it disappears underground. Let's drill a couple of wells. If you drill a well into one of these confined aquifers, and you're in a locality now where the pressure surface is above the ground, what's going to happen? Water always rises to the pressure surface. That's a secret. So it squirts up in the air. If we moved over a little bit and drilled another one, as long as the pressure surface is above the ground, it'll squirt up to the pressure surface. Note if we drilled a well where the pressure surface came in contact with the ground, the water would rise to the pressure surface, but it would just come to the surface no further. If we went out beyond that, where the pressure surface now has dived beneath the ground level, rise to the pressure surface, but nowhere near the surface of the ground. Question, what do you call wells like that? What do you call the wells that squirt up in the air? Well, everybody knows that. It's an artesian well. Artesian well, by definition, is any well that produces from a confined aquifer. Those are all artesian wells. The ones that squirt up in the air happen to be called free-flowing artesian wells. The advantage of a free-flowing, pretty obvious. You don't have to pump on those. If it comes to the surface, the pressure there may be enough that you could tap onto it and pipe it up to your house or out to your barn or out into the field for irrigation. The other guys, you see, you do have to pump on them. So the idea about these free-flowing artesian wells, they're great because once you drill your well, you see, it doesn't cost you any more money to get any kind of water out of it because it just comes to the surface itself. Well, it just so happens that a lot of those aquifers out there in the Great Plains, for example, are confined systems. For example, I'm thinking of the Dakota sandstone, one of the more famous ones. Whenever the settlers started moving out there, and they started drilling their wells, this would have been in the early, mid-1800s, almost every well drilled into the Dakota sandstone was a free-flowing well. In other words, the water came to the surface on its own. I think that certainly is one of the reasons why that entire area became such a great agricultural place fast, because the water, once they drilled their wells, was basically free. They had all the water they needed to do all the irrigation they needed to grow the kind of plants that needed a little bit more water than an arid, semi-arid region would provide. So anyway, that's a typical example of a confined aquifer. So they're totally different kind of scenarios. Well, the next thing we would like to talk about, I think, is just exactly how you get the water out of the ground, so we'll talk about that in the next lecture.